Hi guys, hope you're having a good week. This is a key for the midterm review packet, and I'm just going to do pages 1 and 2 today, or units 1 and 2 rather, and hopefully that'll keep you, if you wanted to go along with it and see how you did. You can check it as you go, or you can wait and I'll post the key on Friday. It's up to you if you want to watch the video and go on. All right, so let's talk about some of the things we did way back in September. It says translate the following expression: 9 less, okay, less is subtraction, than 5 times a number. Now, this word I call the old switcheroo word. So whatever it comes after, it goes first. So 5 times the number, I'll use n, less 9. You could use x, you can use anything. So it will go like that. Order of operations we did way long in the past. Remember PEMDAS, if you're working on this. So I'm going to start with what's in the parentheses. I'm going to leave the 4 times. I'm going to make that 4 squared divided by, I'm going to do this parenthesis 2 to the third. Then E, exponents. So I'm going to leave 4 times, but 4 squared is 16 divided by 2 to the third is actually 8. Then I'm going to work back and say, okay, multiplying and dividing left to right. So this is what I'm going to do next. And that gives me 64 divided by 8. And so my final answer should be 8 if you're working through that one. Okay, and then we get to the part that I know you're really good at, equation solving, but maybe we're a little rusty. When there's variables on both sides, don't forget that you can draw railroad tracks if you need to, but you can combine everything on each side. So 6x minus 3, if I put together those two, and on this side, 8x minus x would give me 7x minus 3. Okay. Generally, I try to move the smaller one to be on the same side as the other x. So when that happens, I have negative 3 equals x minus 3. And then when I add 3, I end up with, hey, negative 3 and positive 3, that's going to equal 0. 0 is okay to have as an answer. It just would mean there's one solution there. Okay. Letter B, distributive property. I know you guys know how to do. So it's just 18 minus 12x. And over on this side, it's negative 12x. And don't forget the double negative. Negative 2, negative 9 is going to turn into positive 18 on that side. If you want to set it up like that, go ahead. Doesn't really matter what side you do. If I started to do this, I just like to add more than I like to subtract. So I do it that way. But it doesn't really matter. So I get 18. But what is going to happen is, notice you get the same thing on each side. So when that happens, that is, remember we used to say that's the identity. And another way to say it is it's all real numbers, because it's exactly identical on both sides. I actually could have noticed that right here, because 18 minus 12x is the same as negative 12 plus 18x. But either way, I can keep going until I get the same thing on each side. Okay, third one, distributive property again goes first. So 12k plus 30 minus 3k equals 66. And this time, just combine like terms. So 12k minus 3k. Do that in my head. I don't write it down. And I get 9k plus 30 equals 66. Take away the 30. And then it's a straightforward 9k equals 36. Divide by 9. K, it turns out to be 4 for that one. One solution, easy peasy. Letter D, same thing. Always start out by distributing. So 32 minus 16x equals 12 minus 20x plus 4x. Okay, I might divide this up. Nothing really to simplify on the left, but I definitely could put together negative 20 and positive 4. So I end up getting 32 minus 16x equals 12 minus 16x. Now, this is a little different, because if I add 16x and I add 16x, I will wipe out both x's and end up with 32 equals 12, which is totally not true. So when that happens, remember it's the empty setter, we say that it has no solution. Okay, so that's how we do that one. The very last one, we haven't done one of these in a while, but I'm going to do the clearing fraction method to do this, and we've looked at this before, but we haven't done it in a while. So when you want to clear the fractions, because nobody likes working with fractions, so you can look at the denominators and say, what's the first number these both go into? Well, the least common denominator would be 9. So remember, we used to say, wrap it up, everybody's going to get multiplied by 9 then. This one, 1/3 times 9, and negative 7 times 9. So when that happens, if it's not a fraction, you're just going to do 9 times 3, which is 27. But if it is a fraction, your denominator cancels with your numerator. And so you really only have 1. So you have 1 times 2, which would be minus 2b, equals, same thing here. If I have a fraction, my 3 will go into my 9 3 times. So it's 3 times 1, which is 3b. And on the last one, it's not a fraction, so I'm just going to do 7 times 9 and get 63. Okay. Now, I'm going to look and say, all right, I got to get the b's on the same side. I like adding better, so I'm going to add 2b. And I'm going to get 27 equals 5b minus 63. And then I'm going to add 63. And I'm going to end up with 5b equaling 90. So if I divide both sides by 5, I'm going to go over here, b turns out to be 18. So take a look, maybe slow down, rewatch that if you need to. You've got to clear the fraction by using what the common denominator is. Okay, so that's unit 1, this page. Hopefully you did all right. See how you did. You can always let me know, too. I appreciate any comments or emails. I'm doing good. I've only missed one, something like that. Okay, the next page is, they're going to talk about geometry. So unit 2 was geometry. And we did a lot of geometry right up until we were gone. So when you look at this one, you say, okay, if I look at this angle and this angle, the ones that are labeled, they are both acute, which means they have to be equal on parallel lines. They're actually called, if you remember, the alternate exterior angles, and they are what we say congruent. So if that's the case, then we say, well, then that 90 minus 9y should equal the 6y. All right, so then I say, okay, let's add 9y, get it on the other side. So 90 equals 15y, and if I divide by 15, then y should equal 6. So if y is 6, that means I can substitute 6 in for either one of these, and it's probably easier if I just do this one, and I do 6 times 6 equals the angle, then the angle should equal 36 degrees for both of them. Okay, they're both going to be 36 degrees. And you can prove it by doing 90 minus 9 times 6. That's 90 minus 54. Guess what? Also 36. Same thing. All right, but you only had to do one to figure it out. So that's what those angles are. Okay, then the next thing on number 5, it says, in the following diagram, the two angles are supplementary. So we got to remember, what number is supplementary? It's 180. They make a line, they equal 180. So that means, remember, you can see the half circle, and the half circle is the 180. These two together, so 5x plus x, has to add up to 180. So we got 6x equals 180, divide by 6, divide by 6. That means x equals 30. So the little angle, this side, is 30, but 5 times 30 is actually 150. So that's this side of the angle, and that one's the other. Okay. And then we learned a lot about triangles, and of course, triangles also add up to 180. I think they didn't really put something there, but I think they want you to find that. So we'll just put an X in there for that. So basically, when you look at your three angles, one of them's X, one of them's 30, and the right angle, of course, is 90. And again, all that should add up to 180. So X plus 120 equals 180, and then you subtract 120. So X turns out to be 60. So that missing angle is 60 up there. Okay? And that's just, hopefully we remembered a lot of that, but a little bit of review. All right, last page, other geometry question. Oh, wait, I'm sorry, there's 2 more pages. We'll go for it, but they go pretty quick. All right, so it says the measure of angle 4 is 60. Whenever they tell me something, I try to label that right away on my diagram. There's 60 degrees. Find the measure of the missing angles. Tell how you know their measure without using a protractor. Okay, well, guess what? Remember, the one that's right across from it also has to be 60, and those are known as vertical angles, right? If they're diagonally across from each other. Vertical angles are congruent. So that's how I know angle 2 is 60. And then, of course, if I look at this, this is a line, so this makes a half circle with it. So basically, 180 minus 60 is 120. So angle 1 would have to be 120, and then of course so would angle 3, because they are vertical as well. Vertical are the opposites, don't forget. And so that has to be 120 also. Okay. All right, so that's how you do that one. Number 8, you're back to looking at a pair of parallel lines. So when I look at that one, and I think to myself, okay, what kind of angles are these? So I look at them both. Well, they're pretty big, so they're both obtuse. I can tell they're both congruent, and they're both in the same position. And if you remember what that's called when they're in the same position, that's called corresponding, because I could push the top angle down and it would land on top of it. Corresponding angles, and so they are congruent. So again, both being obtuse, both if I slid them down, they'd land on top of each other. That means that if I want to figure out what x is, I'm going to set them equal to one another. So I'm going to say that x plus 95 has to equal 4x minus 10. And when I subtract the x on that side, I'm going to get 95 equals 3x minus 10. And I'm going to add back 10. So I'm going to get 105 equals 3x, and I'm going to divide by 3. So that turns out that x would be 35. So if x is 35, this is what part B says. Sorry, missed that a little bit. You can look at that. What is the degrees in ABC? So I got to look. Where is ABC? All right, well, ABC is this guy right here, this little angle. So that's acute, so I know it can't be over 90. So one thing I'm going to have to do is actually I'm going to have to plug in 35, and I'm going to add 95 to it so that I actually know what the big angles are. So if I add 35 and 95, I'm going to get 130. So the big angles are 130, which means the little angles would have to be 50, because they have to add up to 180. Let me show you again at the bottom. So I took my 35, I plugged it into the one that said x plus 95, so 35 plus 95 is 130, and then I subtracted. So that means ABC, which is an acute angle, would have to be 50. Okay. All right, and the last of the geometry questions. Again, when I'm looking at this, I see a triangle. So there's two ways to do this. If you remember, these are called the remote interiors. They're the farthest away. This one's also a remote interior. And this angle, because it's outside the triangle, would be an exterior angle. So there are two ways to look at this. The exterior angle is always equal to the remote interior plus the other remote interior. So I could quickly do this and say, well, that means x is equal to 32 plus 28. And that means x is equal to 60. Okay. Now, if I didn't want to do it that way, my other option for that is always, of course, to say, hey, I know triangles add up to 180. I could pretend this is y and say, okay, 32 plus 28 plus y equals 180. 60 plus y equals 180. So y would have to be 120. So if this inside angle is 120, then the outside angle that's supplementary to it, that's right next to it, would have to be 60. Okay, so that's the other way to do it. The first way is a little shorter, but you can still do it. Okay, on this one, little similarity question. So I'm going to use, it wants to know LM. Okay, so there's two ways to do this, of course. So LM is this one at the bottom. So for me, I'm kind of a proportion fan. I like to say, all right, I'll make a proportion. So I'll say x is the same in the same position as 20 on the other triangle, the same way that 24 is in the same position as 32. So then I would probably use cross multiplying to answer this question. So I'd say 32x equals 480, divide by 32, and that turns out to be 15 centimeters. Now, the other way you could obviously do it is you could figure out the scale factor by doing 32 divided by 24. Oh, I don't have my calculator with me, so let's see. If I divide that by 8, it's like 4/3. So it's 1 1/3. So you could take 20 and divide it by 1 1/3. Little bit of a pain in the neck, old school fractions. That'd be like 20 divided by 4/3, which would be 20 times 3/4. Oh my gosh, sixth grade math. I was doing this with my son today. You have to cancel and you would get 15 that way. Or you would use a calculator, but I went a little old school on you. We didn't have a calculator. Most of you do. So you could do it that way if you're going to do the scale factor. The scale factor would be that. Okay, finally, last question. In this diagram, what do they tell me? Angle 13 is 61. So, all right, I'm immediately going to label that 61. And angle 9 is 46. All right, where's angle 9? 46. So they want us to label all of these angles, given that I just know those two. All right, it's actually not that bad. Remember, anybody who's across from each other has to be the same. So 11 and 13 are vertical angles, so they're 61. And that would make 7 46 because it's vertical to that. Okay, second thing to know too is that any angles that are next to each other and make a line have to add up to 180. So if I think about 180 minus 61, that's 119. So 119 there, 119 there, because those are vertical. All right. Same thing over here. If I take 180 minus 46, I'm going to end up with 134. So that means angle 8 is 134 and angle 10 is 134 because they're both vertical to each other. Okay. Now, where are we going from there? Well, we do know these lines are parallel. So we remember there's a thing called alternate interior. They make the Z. So if that's 46, guess what? That's 46. Same thing on here. The Z says 61. So that's 61. Okay. Now, any line, so 2, 1, and 6 form a line. You can see it right there. So that means that 61 and 46 add up to 107, which means that the missing angle 1 would be 73 degrees because it has to add up to 180, which then, okay, I'm done because I can do all vertical angles. So that means angle 4 is 73, angle 5 is 61, and over here angle 3 is 46. And then we've got them all. So it's all based on 180 and knowing that vertical angles diagonally across from each other have to be the same. All right, that's all for today. We'll pick up on the other two another time. Hope you guys are having a good day. We'll talk to you later. Bye.